capital F, small f, capital G, small h. That's a cross between these two parents. These two parents are not exactly the same in terms of their gene. So we are going to bring out their gametes first. Then we are asked to itemize the gametes of the parents and the offspring. So we'll first of all get the gametes for each parent, parent A, parent B. I think this should be the father with this sign. So this sign for male. So this should be the sign for female. To cross in the other way around. But whichever, the sex is not a problem. What is a problem is the genotype. So this is the first genotype for the first parent, the P1, the P, the second parent in the first cross. So, okay. Welcome to Sa Majesty Easy World of Science. Today, we will take a look at polygenic inheritance. Polygenic inheritance is just a type of inheritance whereby a particular character is controlled by more than one or two alleles. This is unlike Mendel's laws of genetics. Normal Mendel, where we talk about monohybrid and dihybrid cross. Here we are considering a character that is controlled by more than one pair, two pairs of genes, up to 3, 4, 5. So the crossing may be very difficult. First, we will take a look at how do we get the number of gametes in a given genotype. Take, for example, if you have such genotype like this, capital C, small b. So for you to get the possible gametes that will come out of this genotype, you have a formula which says 2 raised to the power n, where n is equal to the number of heterozygous alleles. So here we have only but 2 heterozygous alleles. This is homozygous, therefore our n is 2. So the total gamete we will get is 2 raised to the power 2, which will give us 4. So to get the gametes out of this genotype, what you have to do is very, very simple. Since this is the same, we take only one. That's A, capital A, capital A. You can only use one. Therefore, we have A being constant, then we have capital B, small b, then capital C, small c. And it's just like permutation and combination. In how many possible ways will they combine? You can take the first letter all through, A, B, C. That is A, B, C. Then you take A, small b, capital C. Then you take A, small b, small c. Then you take A, B, that's A, capital A, capital B, small c. So these are the 4 possible gametes that will come out of this genotype. Okay, let me simplify it a bit again. Let's assume this is a cross between 2 mulatto parents, A, B, C. To get the gametes here, we have 1, 2, 3 heterozygous alleles. This is pair 1. Pair 2, pair 3, and they are all heterozygous. And remember, we have 2 raised to the power n, where n is the number of heterozygous. Here, our n is equal to 3. Therefore, the total gamete we will get is 2 raised to the power 3, which will give you 8 possible gametes. Then look at the easy way to get the gametes without even memorizing. This will help when you even have up to 4 pairs, even 5, 6, 7 pairs of genes. Watch this, because you say A, B, C. Some may get it confused. Let's just take a 3 or a little expansion, whereby we are going to use first pair to multiply out everything in this bracket. We will take A first to multiply everything here, then take this smaller a to multiply everything here. Thereby, what we have A, then we have a branch. In this branch, you jump this and place pair 2. Then another branch again, you place pair 3. Capital C, small c. Then the same thing is applicable here. Place capital C, small c. Yes, we are done with that of A here. Then next is we bring that of small letter A. The same thing applicable. Here we have capital B, small b. That's when you write this first letter, first branch, you pair up this first one, then the second one, each, you still have capital C, small c. The same thing applicable here, small c. So to get the gametes, coming here, you have straightforward. First gamete is A, B, C. A, B, C. Then the other gamete is A, B, C. That's capital A, capital B, small c. Then this one will be in this direction. Capital A, small b, capital C. Then this will be capital A, small b, small c. Then coming to this small letter, is just the repetition of this, but we replace now this capital letter A with small letter A. But let's go. We have small letter A, capital letter B, and capital letter C. Then here, small letter A, capital letter B, and small letter C. So we have this and this. That's the direction. This one will now be small letter A, small letter B, capital letter C. Then this will be small letter A, small letter B, small letter C. And when we count, this is 1, 2, 3, 4, 5, 6, 7, and 8. We have succeeded in getting the gamete for this particular genotype. So this is the simplest way. This is also applicable if we have more than 3 pairs of alleles. Let us see a situation where we have more than 3 pairs of alleles. Let's take 4 alleles and see how it works out. Okay, let's see a situation where we have A, capital B, small b. Then we have capital E, small e, capital G, small g. We have pair 1, 2, 3, and 4. And they are all heterozygous. And remember our formula, 2 raised to the power n. In that situation, our n is 4. So 2 raised to the power 4 should give us 16. That's 2 times 2 times 2 times 2. 2 times 2, 4. 4 by 2, 8. 8 by 2, 16. So we are expected to get 16 gametes out of this genotype. Let's see how it works. Using that my tree diagram, what it means is that we will use this first pair to expand. That's to multiply everything inside this. So we will have that. We take first letter, capital A. Then we have a branch. Okay, let me come down because this branch will expand well. Then you place this pair 2, capital B, small b. Then on each one also, again, you place this pair 3, capital E, small e. Then the same thing here, capital E, small e. Then we take further, because we have not gotten to that of pair 4, you still expand, place capital letter G, small letter g. The same thing here, capital letter G, small letter g. Same thing here, capital letter G, small letter G. Then capital letter G, small letter G. So let's try this. Remember, this is only for capital A. We'll still do the same with small letter A. So this will give us 8. So let's go. The first pair should be capital all through. That's dominant. All through. Homozygous dominant starts it and homozygous recessive ends it. We have 1, 2, 3, 4, which will now give us what? A, B, E, G. Then let's go this way. 1, 2, 3, 4. That's A, B, E, small g. Then the other direction is 1, 2, 3, and 4. 1, 2, 3, 4. So we have A, capital A, small e, capital G. So we take the other direction. 1, 2, 3, and 4. Which will give you capital A, capital B, small e, small g. Then we are done with this branch. We come down here, we have capital A, small b, capital A, small b, capital E, capital G. Then we take 1, 2, 3, 4, that's capital A, small b, capital E, small g. Then the other way should be capital A, small b, small e, capital G. Then we have capital letter A, small b, small e, small g. So we're supposed to have 8. 1, 2, 3, 4, 5, 6, 7, and 8. Therefore, we repeat the same thing this time around using the small letter A. Remember, the second pair. Second pair here. We will repeat the same 3 here. So we have this to give us capital B, small b. Take to this pair 3. which will apply to all of the branches. We take to this one, capital G small g. Then we take the same thing here, capital G small g, capital G small g, dominant G, recessive G. Okay, it is the same thing. The secret is replace this capital A throughout with small, because the 3 remains, only that this capital letter A, that's dominant gene A, was changed by recessive gene A. So what we have now is we just take it from the beginning, or we replace everything with small letters. What will it be? The next gene here should be small a, capital D, capital E, capital G. So the second one should be small a, dominant B, dominant E, recessive G. Recessive A, dominant B, recessive E, and dominant G. We have EEG. Okay, let's take it easy. So this is where we stop. So we have, sorry, small letter should be here. So we come down here, it becomes small a, B, small E, capital G. Then here will be small throughout. So, to know you're correct, what starts it is homozygous dominant, and what stops it is homozygous recessive. This should be 16 gametes, 16 possible gametes that will come out from a parent that have this genotype. That is 4 pairs of genotype. That is in polygenic inheritance. It may stand as tetrahybrid cross also. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you go down now to your Punnett square, if this happens to be versus another parent like this, what you need to do is a square that will have a 16 by 16. If the cross is between the parents with the same number of heterozygous allele. So we have settled the problem in providing the gametes from a genotype. It is very obvious now that you can get a gamete whenever you are given a genotype. Now let's go to a more complex one. Let's now use it for crossing. If we have a cross between a parent having this genotype, this is an assignment for UNN students, and it's giving them a little tough time, but look at the easy way. Then versus another parent that is having this type of okay, capital F small f, capital G small g, small h. That's a cross between these two parents. These two parents are not exactly the same in terms of their gene. So we are going to bring out their gametes first. Then we are asked to itemize the gametes of the parents and the offspring. So we'll first of all get the gametes for each parent, parent A, parent B. I think this should be the father with this sign. So this sign for male. So this should be the sign for female. A cross in the other way around, but whichever, the sex is not a problem. What is our problem is the genotype. So this is the first genotype for the first parent, the P1, the P, the second parent in the first cross. So we'll get this gamete first. But before then, remember that how to get the number of gametes in a given genotype is 2 raised to power n, where n should be the number of heterozygous allele present in the genotype. So if we have homozygous allele throughout, no matter the pairs, even if it's 20 pairs of homozygous allele, what it means is that we have only but one. And it means, sorry, if we have all through homozygous allele, let's assume A, B, B, C, C, D, D, G, G, H, H, 1, 2, 3, 4, 5, 6. This can only get, but we have 0 heterozygous allele, so we have 2 raised to power 0. And remember, every number raised to power 0 should be equal to 1. That means the only possible gamete this one can get is nothing but A, B, C, D, G, and H. That's the only gametes they can give. But here we have both homozygous and heterozygous. So let's calculate let's get the gametes of the first parent. Need to clean this. Okay, the gametes of the first parent, that's here, we first calculate the number of heterozygous allele. This one is homozygous, so you shouldn't determine. Heterozygous, this is number 1. This is heterozygous, also number 2. This is homozygous, homozygous, homozygous. So it means we have only but 2 heterozygous allele, which means our n is 2. So the total gamete we will get here should be 2 raised to the power n. When our n is equal to 2, it means that the total gamete should be 4. That's 2 raised to the power 2. Let's see how it works. Look at the secret. Since this is homozygous, you just take 1, because they cannot get any 2 type of gamete except the same thing, because they are uniform. But this one that have dominant and recessive have 2 possibilities, either getting the dominant form of this gene or the recessive form. This one, the same thing. So what we will do first is we will pick 1, 1 here, which means under this we take only 1A. Here we'll keep it constant. That's the heterozygous ones will be written exactly. Then this one that is homozygous will take only 1F. We'll take only 1G here, take only 1H. Therefore, what we are combining only is this. It means that A, F, G, H should be constant for all the gametes that we will provide. They will only vary by their contents of these 2 heterozygous allele. Therefore, we will see the possible combination of this and hold these ones constant, and we'll get the gametes. So let's go. We are now only trying to see the possible combination between this and this. You can use your direct discretion, which is take capital letter throughout, capital letter B and capital letter E. Then you have also capital letter B, small letter E. Then we can have small letter B, capital letter E. Then we can have now B, E, T. That's small letter, small letter. So you have 1, 2, 3, and 4. So these are the 4 possible gametes. But you have to go back and add these constants. We have A, F, G, H is constant for each of them. So when we add it to the first one, the gametes number 1 should be B, E, A, F, G, H. The other one should now be capital B, small e, A, F, G, H. The other one will now be small b, capital E, A, F, small g, H. Then lastly we have small b, small e, A, F, G, H. So these are the possible gametes that will come out from the first parent. We now keep this. That's the parents of one of the gametes of one of the parents. This may be that of the father probably. Then we'll take the second one here. So let's take a look at these gametes of that of the father. So let's assume this one should be the mother or the female type. Go back to the original. This is homozygous, homozygous, hetero, 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 and homo. So we have 1, 2, and 3. We have 3 heterozygous. Then other ones that are homo will be fixed constant like we did here. So what we have, 2 raised to the power 3, we are expected to have 8 gametes at the end. So we will combine A, E, F, G, A, E, F, F, G, G. Sorry, E, E, F, F, G, G. So using the 3-branch formula I gave to you, what we will have is these 2 will multiply everything here. This should be per 2, per 3, because here is per 1. So we take capital letter E first. We place capital F, small f, another branch to complete the per 3, capital G, small g, another branch here, capital G, small g. And the other one should be for small letter E, capital F, small f, then capital G, small g, capital G, small g. So this should be E, F, G, dominant all through. E, F, small g, E, small f, capital G, E small f small g, then small e f small e capital F capital G, then small e capital F small g, small e small f capital G, and finally small e small f small g. So you have 1, 2, 3, 4, 5, 6, 7, and 8. So we'll make our Punnett square. Though this is no longer a square, but this should be the normal thing obtained in genetics. I wouldn't know how the man gave the assignment, but all the same, this is the basics for the polygenic inheritance involving this case. Because homozygous alleles have only but one form. It is the heterozygous that have two forms, and therefore we don't count homozygous. So having brought this out, you will go back, take 1a constant. So every of these will add to it a, capital B, and small h, because we will take 1 h here. Out of these 2b, we'll take 1. Out of these 2, we'll take also a. So after getting all this, we'll keep adding to all. Small a, so we now go to the Punnett square. Go to the Punnett square. Well, I need to write down these gametes. Okay, let's use here. Okay. Started? Mm-hmm. Then you use this pattern and fill other boxes. But pair genes, like don't write mixed up genes. Like here you cannot say B, E, F, G again. But when you pick B, finish with B, that's B, B, which is here. E, E, which is here. F, F, dominant, dominant. Then G, and we took A first, or capital A, small a. That's just it. And you take it and bring out, so the total offspring should be 32. So we'll go using, since it is 6 pairs, there will be like 6 times 6 or so. Such thing will give a bigger number, 256 or more. But this should be the thing that is scientifically correct. So the second one is done based on the same thing. We'll just show you a quicker glance on that second question. It is done based on the same pattern. Remember to subscribe to Sir Majesty's World and ask your question in any of these my steps, that because I may be too fast, anything you don't understand well, ask your question in the comment box. And you have to subscribe because we still have more tutorials, the easy way out, because your lecturers will give you more assignment that you find difficult to solve. Sir Majesty's World Science channel is here for you. Thank you. Let's go to the next question, which is number 2. But we shouldn't waste time. It should be a quick glance. Focus on that.